We're at go2math.com looking at some calculus. We're under the numerical approach, finding limits numerically. And we're going to be looking at this particular problem here. Alright, so we want to evaluate this limit numerically. This is the limit as x approaches 2 of 1 minus 7x quantity squared over 1 minus 7x. 1 minus 7x, that quantity, yeah, okay. Let's head over to the whiteboard and see what we got. Okay, so let's go ahead and write that out again. This is the limit as x approaches 2. That's what it was. And we had 1 minus 7x quantity squared over 1 minus 7x. Now I'm going to write this as f of x is equal to 1 minus 7x squared over 1 minus 7x. Right, so this could actually have been rewritten as that, limit of f of x approaches 2. Some people say the limit of x approaches 2 of f of x, however you want to say that. Anyway, it could be written like this, so you need to know this. Now, there's another way of writing f of x, and that is, let's go ahead and factor this. Minus 7x and 1 plus 7x over 1 minus 7x. And we could actually, we got term on the top, term on the bottom that we could actually cancel out. And you're probably going, wait a minute, those are two different functions. Right, so this does not look anything like this. Okay, these two are equal only if we state the domain. We have to state the domain here. And the domain is really all real numbers, but x cannot be whatever we plug into this and get 0 in the bottom. Right, because that would become undefined there. And that would be 1/7. So these two functions are the same, but we must state this right here. We have to state this. X cannot be equal to 1/7, right? So we have to throw that number completely out of the domain there of this, because the domain of this function is actually all real numbers. But we must state this, so this way these are both now going to be equivalent. Now if we were to look at their graph, and that's kind of the real reason why I did that, on top of that's what you're going to do a lot of in the next section. If we said, okay, let's see, slope 7 cross 1, I don't know, something like this. It's something of this nature here. And we're going to go ahead and state that this is 1/7 right here, and we got a missing point in the graph, okay, because that's where it's undefined. All right, we can't use it, therefore it's got an open spot in there. But we're really interested at 2, and we'll say 2 is out here somewhere. All right. Now, if we took 1/7 and plugged it into this guy here, what happens? It breaks down. The function breaks down, and we don't have a clue of what that y value is. We wouldn't know where that hole is actually located. So, but if we use the limit, we ask the limit to find where this hole is at, well, that would be good, because that would actually tell us then where this missing point is if we use a limit. But we can't use the function to find out, except we can do this numerically. In other words, now of course we're focused on 2 here. If we took numbers real close to 2 on the left hand side and plugged them in and kept doing that, but we can't use 2, but we can get real close to 2, we can actually get a good approximation of where this actual spot is, right? When we plug 2 in to the function. Now you're saying, but we can plug 2 in and we know where that's at, right? But you got to understand, we're using the limit here, okay? We're using the limit to do this. And we couldn't plug 1/7 into it find out where the hole is, so we're going to pretend we can't plug 2 into this either. So this is how we're going to do this. I'm going to say, okay, let's take a number close to 2 on the left hand side. And what about 2? And we'll subtract off 0.1. Alright, which is really f of 1.9. Okay, and then we could get a little closer to 2, 0.01, and that's going to be f of 1.99. And so as we do this and get closer and closer and closer to 2, we're getting closer and closer to, I should stay right here, we're getting closer and closer, we'll call this L right here, this number, wherever this is at, we're getting closer and closer to L, and that's what we want to do. See, that would also get us closer and closer to that hole if we were doing it at 1/7. Now once we do that, let's come in from the right hand side and do the same thing. So this time we're coming in from the right, so we're going to, you know what, 2 minus, yeah, plus 0.1, which is f of 2.1. So we look at that number, then f of 2 plus 0.01, which is f of 2.01. Right, so we're looking at these numbers, and as you can see here, they're both going to be converging towards the same number. When we come in from the left hand side, right, these are two separate ones here, coming in from the left hand side and then coming in from the right hand side, they should be converging on the same number. Now if they're not and they're going off in two different directions, that means that this limit doesn't exist. Okay, so it has to be the same coming in from the left and coming in from the right. They got to be converging on this point right here. Now let's actually move over to the back to the web page, and I'm going to hit help here, and hopefully we're going to be able to take a look at that. So we're approaching 2 from the left hand side. So as you can see here, we got 2 minus 0.1, right, which it's revealing itself here, 14.29. So we're getting closer and closer to, remember, to 2 from the left hand side, and we can kind of get an idea of what this number is probably going to end up being, as if we let, you know, 0.000001, we get an idea of where this number is converging towards, right? And it looks like it's converging towards 15 to me. And then of course if we come in from the right hand side, as you can see, so this is coming, as you can see here, this number's getting closer to 15, and this number's getting closer to 15. Therefore we can conclude that this limit right here is probably going to end up being 15, and of course it is. So that's all there is to evaluating the limit numerically, and that's all that the limit is about at this point in time in your math career that you need to be thinking about. Alright, I mean, that's it. There's nothing to it. Okay, easy to do. Alright, so let's move on to another problem, and I'll see you in the next problem. Bye.